As Betsy said, my name is Ann Urick. I'm an applications chemist at Teledyne Tekmar, and I will be today's webinar presentation will discuss methanol extractions of high-level soils. Teledyne Tekmar currently offers the Atomx. The Atomx is a purge and trap concentrator and multi-matrix autosampler that can not only run waters and soils, but also offers automated methanol extractions. The advantage of the Atomx will also be discussed in this webinar. So a quick purge and trap overview. Sample is placed in a sealed vial. There is vapor space above the sample. The VOCs in the sample will move in and out of this vapor space in order to reach it. The sample is purged with an inert gas. The sample is never able to reach that equilibrium because the VOCs that move into the vapor phase are constantly being removed by the purge gas and swept onto the adsorbent trap. Trap acts as a short GC column, trapping the more volatile compounds on the stronger adsorbent portion of the trap and the less volatile compounds on the adsorbent portion of the trap. The trap is then heated and backflushed with inert gas, and the analytes are desorbed onto the GC column for calibration and analysis. There are two techniques for purging the sample. One is a water matrix is purged in a vessel with the purge gas going through a frit in order to disperse. Second is a low-level soil, has a deionized water added to it, and sample vial, and the sample is then purged through a needle sparge in a closed vial system. When a solid waste sample exceeds the working calibration range used for low-level analysis, the U.S. EPA recommends methanol extraction. Methanol extraction is a sample preparation technique for GC and GCMS. U.S. EPA method 5035, there are two sample collection techniques. First method involves collecting a bulk soil sample in the field. In the lab, the bulk soil is dispersed in a water-miscible solvent, such as methanol. Next, an aliquot of the solution is added to 5 ml of deionized water, and finally the sample is purged. Second option is to collect a soil sample and add it to a pre-weighed vial containing a prescribed amount of methanol, and an aliquot of this solution is purged. Low concentration soil method is generally used for samples with a volatile organic compound concentration below 200 ppb. Also, when the concentration of your sample exceeds the 200 ppb level, you can overload your trap. These are the two reasons for methanol extraction. Methanol extraction allows for both the analysis of VOCs above the 200 ppb calibration range and also helps to avoid overloading your trap. Teledyne Tekmar's Atomx is a purge and trap concentrator multi-matrix autosampler. The Atomx is capable of running water and soil matrices as well as methanol extractions. This webinar will discuss methanol extraction capability of this instrument, but also the extraction study done with the Atomx. However, before the methanol extraction discussion, I would like to give a brief introduction of the beneficial features of the Atomx. One of the beneficial features of the Atomx is the sample carousel. The new carousel offers 80 positions for 40 ml vials. The tray is removable for easy sample loading and unloading. There's also an optional chiller tray available for the analysis for analyses requiring holding temperatures of 4 degrees Celsius. So you can hold your samples cold if you want to run over the weekend and still load all your extractions on. The carousel autosampler removes the XYZ pick and place sampler errors. We have been using carousel since the release of the HT3 and is currently employed with Fusion and the Torch TOC systems. It has simulated a 2-year running time without error with the Atomx. Atomx is equipped with the patented 3-stage needle. This needle enables the system to have water and standard for soil samples, purge soil samples, but also the system can perform sample removal and dilutions for water and methanol extraction. There's a vial heater for heating samples from 35 to 100 degrees Celsius. The vial retraction system aids in removal of any soil that might be stuck on the side of the needle. Finally, the system has a heat soil valve and a 24-inch trap return line, shortest soil path on the market. Sample pathway features of the Atomx are a small bed volume, Siltec-coated sample pathway, reduced soil-side pathway decreases sample peak broadening, water management technique superior to others, the patented three-stage needle, new sample heating cup attached to the needle to prevent any heat loss. Atomx comes equipped with a 27 range which allows sample volumes in 1 ml increments. It's also capable of performing dilutions of up to 1 to 100. The Atomx comes standard with 3 standard vessels, which are able to spike samples in 1, 2, 5, 10, and 20 microliter increments. The 3 standard vessels allow for extractions to be spiked with surrogate before the extraction and internal standard before the sample is sent to the Sparger vessel during purging. Finally, the Atomx has a multi-port valve for sample water, methanol, and drain controls. Liquid handling features of the Atomx are stepper controls for syringe movement with sharp volume pull, sandwich delivery in conjunction with sweep port enables accurate volume delivery to the glassware or vial, ability to pull small volumes down to 50 microliters for methanol extraction, and the 8-port stream select valve which allows all the liquids to be used. The Atomx system utilizes Teledyne Tekmar's proprietary number 9 trap and a mini U-shaped condensate trap. This combination aids in water management and is better suited for handling the increased volumes of methanol required for the extraction technique. The entire sample pathway is heated and the sample line pathway inertness. Finally, due to the efficiency of the trap heating power, there is an interlock switch when the trap door is open to prevent any accidental injury. Sample gas handling features are the heated GC transfer line, a heated 6-port valve, and a heated sample 4-way connector with a 1-piece mount. Siltec-coated mount and assembly and sample tubing for inertness. U-shaped analytical trap and condensate trap for better water management. Finally, the Atomx offers the mass flow controller. The mass flow controller allows for complete mode independence for flow purging through a fritted Sparge vessel or performing a needle Sparge on low-level soil samples. It also aids in increasing sample throughput by shortening bake time. Finally, the mass flow controller allows for automated leak checking. Here is a brief overview of how the methanol extraction is done utilizing the Atomx. First, the sample and stir bar are placed in a sample vial. This is either done in the field or in the laboratory. The sample is then placed in the sample rack of the autosampler. Sample is moved to the needle and raised onto the vial for methanol delivery. Methanol is delivered to the sample with or without spike prior to extraction. Sample is lowered slightly in order for the stir bar to mix the sample without the stir bar hitting the needle. After the sample is allowed to settle for a set amount of time, an aliquot of the methanol extract is delivered to the Sparge vessel along with the deionized water. There, finally, the sample is purged. The following slides will display the instrument flow diagrams for a more detailed explanation of how the automated extraction is done. This flow diagram displays how the methanol is drawn from the Purge and trap-grade methanol bottle into the syringe of the Atomx. Purge and trap-grade methanol can be drawn directly from the vendor bottle. The methanol transfer line needs to be in the methanol. Then the system will draw the methanol from the bottle. The Atomx can be programmed to draw methanol in 1 milliliter increments. The sample already has had methanol added. You can add 0 mils of methanol to the sample and still be able to stir the extract on the Atomx. But please note, the Atomx comes equipped with a stream selection valve for flowing methanol into the 27 range and then dispensing the methanol into the sample vial. However, methanol bottle needs to be sealed as to limit your volatile organic compound contamination. You cannot have it sitting open in the lab due to the methanol being contaminated by any contaminants in the air. This flow diagram shows the flow of methanol from the syringe into the sample vial. In order to ensure that the proper amount of methanol is dispensed into the vial, the system overflows the prescribed amount of methanol. It dispenses the overdrawn portion of the methanol to waste in order to eliminate any air bubbles and dispenses the correct amount to the vial. It is important to note that the system has the ability to add surrogate or spike to the sample here before the sample is extracted. If you look at the flow diagram, you will notice that the methanol flows through the internal standard vessel vial. To add surrogate or spike to your sample, it will be dispensed into the valve and swept into the vial with the methanol before the sample is extracted. However, if you are not adding methanol to your sample, if it's already been added, then you cannot add spike or surrogate due to the fact that the spike and surrogate are swept over into the vial with the methanol. Finally, if you do opt to add surrogate or spike to the sample prior to extraction, the amount of surrogate or spike that can be added is limited to a maximum of 20 microliters. Therefore, the concentration of the surrogate and or spike should be high enough to account for the dilution added. Flow diagram of the methanol extract still. Here the extract is pulled from the vial and into the syringe. Note that during the agitation cycle of the extraction, the sample vial is lowered slightly as to limit the stir bar from hitting the sample needle. After the sample is allowed to settle for the prescribed amount of time, the sample vial is raised up a little further onto the needle and an aliquot of the extract is taken. The syringe is capable of pulling 50 microliters for a 100-to-1 dilution or 100 microliters for a 50-to-1 dilution. This is the flow diagram of the extract being dispensed to the Sparger from the syringe. It is important to note that the DI water is swept into the Sparger following the extract in order to ensure the entire sample extract is swept into the. Also note that the internal standard and surrogate, if not added to the extract, can also be added here and swept over to the Sparger vessel along with the DI water. These are the Atomx Purge parameters, and I will be going over several of them and explaining. Valve oven and transfer line temperature is set here anywhere from 20 to 250 degrees. These should be set high enough to prevent cross-contamination, but not too high as to decompose the analytes. The recommended temperature is 140 degrees. Sample mount can be heated in order to eliminate cold spots in the gas flow path that could lead to carryover and reduced sensitivity. Temperature range is 20 to 100 degrees and the recommended temperature. Water heater temperature can be set from 20 to 90 degrees in order to rinse the sample pathway, the sample needle, and the glassware with hot water. The recommended temperature of the hot water is 92 degrees Celsius. The oil valve temperature can be set from 20 to 100 degrees during operation. It is recommended that you keep the temperature hot during operation in order to minimize delay during operation when switching between water, methanol, and soil methods, and to reduce carryover and contamination. The recommended temperature is 100 degrees Celsius. Standby flow parameter is the amount of flow desired to sweep the sample pathway when the unit is idle. Minimum flow is 0 mils a minute, while the maximum is 500. The recommended flow there is 10 mils. The purge ready temperature and the condensate ready temperature are the set points for the analytical trap and the condensate trap that have to be reached before stepping into the purge mode. This is set 10 to 20 degrees higher than the ambient temperature in order to decrease cycle time. The minimum is 20 degrees and the maximum is 350 for the analytical trap, and the 20 degree minimum and 200 degree maximum for the condensate. Recommended temperatures here are 40 degrees for the analytical and 45 for the condensate. To create a method, you can program the amount of methanol you would like to add to your sample. The amount of methanol that you add is a minimum of 0 mils. A 0 mil methanol addition for soil samples that are collected and added to the pre-weighted vial contain a prescribed amount of water miscible solvent in the field. It is important to note that if you're not adding methanol to the vial, you cannot add surrogate standard sample prior to extraction. If you require surrogate or standard added prior to the extraction, it will have to be added manually. Maximum amount of methanol that you can add is 25 milliliters. Bulk soil samples that are weighed and added to vials in the laboratory. It is important to note that the methanol can only be added in 1 milliliter. If necessary to add smaller increments, the methanol will have to be added manually. Also note that if you're adding methanol to a bulk soil, you can add standard or surrogate to the sample for extraction. The Atomx has the option of having your Sparge vessel heated. If you like to heat your Sparge vessel, the heater must be installed, and if enabled, the heater will remain on in all modes of operation. The temperature range of the Sparge vessel heater is 20 degrees Celsius to 100 degrees, and is dependent on the nature of the sample being analyzed. The Atomx has the capability of programming in your mix speed, mix time, and mix settle time. The mix speed options are slow, medium, fast, and agitate. The mix time and settle times are 0 to 300 minutes. So there are many options as far as how you would like to extract your sample. We have found that a 2-minute mix time and a medium mix speed are adequate for normal soil analysis. You have the ability to alter the setting to meet your individual needs, and as always, experience is the best decision maker. The settle time will greatly depend on the nature of the soil. Those with finer particles generally require longer settle times. Vial position during the methanol fill stage is up higher so as to limit the distance between the soil and the methanol dispersant. However, during the mix stage, the vial is lowered so as to limit the stir bar hitting the needle in order to achieve better mixing. Sample sweep time and sweep flow are the amount of time and flow needed to sweep the sample into the Sparge vessel, and it's recommended quarter of a minute with sweep flow of 100 mils a minute. Purge temp and condensate temp are the temperatures of the analytical trap and condensate trap, and it is recommended that they both be set at 20 degrees Celsius. This is to ensure that both of the trap heaters are off during purge mode and to minimize the amount of moisture staying in the analytical trap during purge mode. Dry purge time helps reduce moisture before desorb by passing dry gas through the analytical trap. The recommended time is 1 minute. Dry purge flow is the flow rate at which the dry gas is passed through the analytical trap during the dry purge mode. The recommended flow is 100 mils a minute. Dry purge temp is the analytical trap temperature during dry purge mode. 20 degrees Celsius is the recommended set point as it is to ensure that the analytical trap remains cool during dry purge. Heating the trap can also lead to loss of analytes. During desorb, you have the option of rinsing the inner stage of the needle with methanol. This is recommended when doing extractions as the needle is exposed to the methanol extract, which has the potential of having high concentration of VOCs. Rinsing the needle with methanol will aid in your reduction of carryover. In addition, should any small soil particles be lodged in the needle orifices, this additional rinse can aid in their removal. The volume you choose to rinse your needle can be anywhere from 0 mils to 27 mils of methanol. The recommended volume is 2 mils. After the needle is rinsed with methanol, the needle will be rinsed with the hot water and then be swept with inert gas. Desorb preheat temperature is trap dependent. Use a temperature of 5 to 10 degrees below the recommended desorb temperature of the analytical trap. This allows the analytes to release from the sorbent and move toward the GC. Desorb temperature is dependent on the analytical trap and also should be set to the recommended temperature of the sorbent of the trap itself. The desorb time should be set low enough to minimize the amount of water transfer to the GC, but long enough to ensure complete transfer of the analytes to the GC. Carryover gas flow rate and the split ratio. During bake, you have the option of rinsing the glassware with methanol. You have the option of rinsing the glass anywhere from 0 to 5 times with 0 to 27 mils of methanol. Recommended volume is 3 milliliters. There is an application note on carryover reduction with the Atomx, and it found that 1 rinse with 3 mils of methanol was sufficient in reducing carryover in water samples to less than 0.25% for the heavy. We're to the end of this presentation, and there will be a list of application notes for you to download if you are interested in that. Due to the fact that methanol extracts contain higher concentration of analytes, glassware and sample path are exposed to these high concentration of analytes. It is important to rinse the pathway not only in water but also in methanol, as this is proved to reduce carryover and contamination very well. During the bake, you also have the option to rinse the Sparge vessel with hot water. You can rinse the glassware anywhere from 0 to 5 times with anywhere from. It is recommended that you rinse the glassware 1 time with 7 ml of water if you are using the 3 milliliter methanol rinse. The combination of methanol and water rinse are very efficient in limiting carriers. The final parameter that I would like to address is the bake flow. The Atomx has a unique feature of splitting off the bake flow and having the inert gas flow through the sample needle. The gas is split off after it goes through the trap, so the trap receives the entire amount of bake flow. After the trap is purged with inert gas, a portion of the gas goes through the needle and the rest is vented. Back flushing with gas also travels through the entire soil purge and return path, including the soil line and transfer line, for better reduction of carrier. Setting up the sample schedule, you have the option of adding surrogate or spike to the sample prior to extraction. Only be done when performing a methanol extraction experiment. Spike must be in standard vessel 3. Software is set up so that the surrogate or spike will be swept over to the sample and extracted when the methanol is added to the sample. Also, note that the minimum amount of surrogate or spike that the maximum amount of surrogate or spike that can be added is 20 microliters. Spike should be concentrated in order to account for the fact that the sample is extracted and only a portion of that extract will go to the Sparge vessel. The surrogate or spike will be diluted along with the extract. Performing a methanol extraction, only a portion of the extract is purged in the Sparge vessel. Setting up a sample schedule, you have the option of 2 dilution volumes. Dilution volumes are based on a 5 ml purge volume. Thus, for a 1 to 100 dilution, 50 microliters of extract will be drawn from the sample extract. For a 1 to 50 dilution, 100 microliters of extract will be drawn and transferred to the Sparge vessel for purging. Due to the possibility of methanol interference when running extractions, the curve was prepared with 1 milliliter of methanol at each calibration point. Therefore, when purging at 5 standard, there will be 100 microliters of methanol in each calibration point, as there would be when running a 50 to 1 dilution during an extraction experiment. In order to test the efficiency and precision of the extraction process of the extraction will perform both automatically by the Atomx and manually by the analyst. Extractions were done with 2 different soil to methanol ratios. There was a 1 to 2 ratio of 5 grams of baked sand and 10 milliliters of methanol, 1 to 1 ratio of 7 grams of sand, and samples were run at 5 different extraction levels in order to test the linearity of the extractions from a low extraction range to a high extraction range. 7 replicate extractions were run at each level in order to reproducibility of the extractions. These are the Atomx experimental parameters for the 5 grams of sand and 10 milliliters of methanol automated extraction experiments. Bake speed was set to medium for 2 minutes. After the sample was extracted, an aliquot of the extract was dispensed to the Sparge vessel. It was rinsed with 2 milliliters of methanol and 7 ml of water. The Sparge vessel was then rinsed in 3 milliliters of methanol and 7 milliliters. This rinse feature enables better reduction of carryover within the system. These are the Atomx experimental parameters for the 7 grams of sand and 7 milliliters of extraction experiment. The only difference between these parameters and the previous slide is the amount of methanol added for extraction. Finally, these are the Atomx experimental parameters for the manual extraction experiments. Samples were extracted and diluted by the analyst, so the samples were run as in water. Since the extraction and dilution was done previous to running the sample, it was unnecessary to rinse the needle in methanol. It was not directly exposed to the extracted material. However, the Sparger vessel still rinsed in methanol as the Azolant 7890 AGC and 5975 inert Excel MSD were used. The J&W scientific column was used with, it was DV624 column with 20 meter by 180 micrometer by 1 micrometer. The 81 split was employed for the study with a 1.5 millimeter column. The oven program was 35 degrees C with isotherm for 4 minutes, then ramped at 16 degrees C for a minute till 85 degrees for 0 minutes, then ramped again from 30 degrees Celsius per minute degrees Celsius for 3 minutes. The total runtime was 14.3 minutes. Finally, the mass spec scanned from mass ratio 35 to 300 at 5.19 scans per second. Here's the summary of calibration and carryover results. The calibration data was calculated using Agilent condensation software. As noted from earlier, methanol compensation was used in order for the calibration results to accurately reflect any methanol interference that might occur with methanol extraction. Dealing with high-level waste samples, system carryover and contamination can be of major concern. Carryover resulting from the Atomx automated methanol extraction method was evaluated by using a 5-gram sample of bake sand spiked with 20 part per million gasoline range organic standard. The spiked sand was then extracted with 10 mils of methanol. 100 microliters of the extract was then diluted into 5 milliliters of deionized water for a final concentration of 200 ppb. This was purged and used as the high-level waste sample. For the 3 subsequent blanks, 5 grams of baked sand, unspiked with any gasoline range organic, were extracted and then analyzed for carryover. Following a 20 part per million extraction, the Atomx reduced carryover to less than 0.4% in the first. This achievement is possible due to the system methanol rinsing function, capable of rinsing the entire sample pathway with clean extraction solvent in between analyses. Capability of the system to rinse the sample pathway in methanol is patent pending. In order to test how well the Atomx extracted samples over an extraction concentration range of 5 ppb to 100 ppb, as they were diluted by 100x, 7 replicate standards were prepared at each extraction level for each type of extraction. The average compound response was plotted against the extraction level. You can see from the result of this study that the response of all the compounds is linear. The data was analyzed for all the analytes in a Wisconsin gasoline range organic mix. This slide is a display of the MTBE and methane and their respective responses as related to the calibration level of the extract. Results are for 5 grams of sand extracted with 10 mils of methanol. This slide displays the results for toluene and ethylbenzene extracted in 5 grams of sand and 10 mils of methanol. This slide is the results for the xylene. And this slide is the results for the trimethylbenzenes. As you can see, the results for all the compounds is quite linear. Finally, these are the results for the naphthalene in 5 grams of sand and 10 mils of methanol. As you can see, the Atomx performs extractions quite linearly from the low-level extraction to the higher-level extraction. Here is a summary of the extraction results. As you can see, the automated Atomx extractions performed as well as the manual extractions. Both of the experimental parameters, meaning 5 grams of sand and 10 mils of methanol, 7 grams of sand and 7 mils of methanol, performed equally well over the entire calibration range. In order to test the accuracy of the automated versus the manual extraction, 7 replicate standards of a 50 part per billion extraction were done both manually and utilizing the automated feature of the Atomx. done with 5 grams of bake sand and 10. See from the results, the Atomx extractions had similar recoveries to the manual extractions. In order to test the precision of the automated versus the manual extraction, 7 replicate standards of a 50 part per billion extraction were done both manually and using the automated feature of the Atomx. It was again done with 5 grams of bake sand pills of methanol. The compound responses of the experiments were averaged, and the percent relative standard deviation was found for both the automated and the manual extractions. See from the results, the Atomx extractions had similar relative standard deviations as compared to manual extractions. This is a graphic of the total ion chromatogram of a 50 part per billion gasoline range organic standard extracted by the Atomx. There are many trap choices available. In general, however, for volatile organic compound analysis, the low carb 3000 or K-trap trap, B-tex trap for B-tex compound, Tekmar number 9 trap are recommended. Tekmar's number 9 trap is very well suited for handling the increased volumes of methanol that an extraction would require. This Atomx is a newly released instrument. There are many more projects and future investigations to be done. Among the methanol extraction projects planned for the instrument are 1. Performing extractions on a full EPA method 8260 list of compounds. 2. Evaluating the performance of the Atomx when extracting different matrices, meaning clay, absorbent soils, mixtures of clays and soils, etc. In summary, methanol extractions are used for high-level waste samples. According to Method 5035, samples can be collected either as a bulk soil or added to a pre-weighed vial with a prescribed amount of methanol already added. Extractions are used when there is a need to analyze samples above the 200 part per billion calibration level or to help prevent overloading the analytical trap. Seen with this study, the Atomx proved to be an excellent system for. At this point, I would like to thank everyone for attending this webinar. If you have any questions, please feel free to email them now, or we can be contacted at the number or email address listed below if you have any questions in the future. Here's the list of the Atomx application notes that are on our website that you can visit to see if you want to download any of these application notes. Here's a list of upcoming webinars that you may like to attend. Thank you again.
All right, great. Thanks, Ann, and thank you all for attending. At this point, I'd like to open it up for any questions and answers. And for those of you who are on the phone listening, if you have any questions, feel free to take your phone off of mute and go ahead and ask. We'll stay on for a few more minutes for those of you who wish to type your questions.